Good. Look at that, a T34. Oh yeah. This. It's 18 January and I'm here with Chuck Wall and Vultures Row Aviation, and it's time for a Birdcage Corsair update. Let's check it out. Here's an example of some of the sheet metal work going on here. This is the piece that mounts right behind the firewall on Lucky Gallon, a racing Corsair from back in the 40s. This is the original piece right here. This is where the engine mounts right through this hole where my thumb is, and look at that, worn out, cracked, and busted right through these rivets here. So they got to form a whole new piece. So they got a huge press back there that they can take this dead soft aluminum, thick dead soft aluminum, and then hammer this curved piece into here. Now here's another one right here, and let me show you on the other airplane where this mounts exactly. Here's a fuselage here of another Corsair. Here's where this piece mounts. Here's the engine mount bolt, and then the wing main spar attaches right here. So it's a critical piece of the structure that was cracked right in here and replaced with a new piece. So here's the mock-up of the engine mounting right over here. And let me see if I can find that spar attach fitting. Here's the wing spar attach fitting that is also part of this critical juncture, which is going to mount somewhere right in here. Here's another example of a wing spar fuselage attach fitting from a wrecked airplane. Remember the Corsairs involved in the soccer wars down in, what was that, Honduras at the time? El Salvador? Well, this is one of them. Here's the center section to the soccer wars airplane. Some assembly required. All right, we're looking at a 2800-8 engine, a rare early model 2800 engine that goes on the Birdcage Corsair. 2 rows of 9 cylinders, 18 cylinders, typical radial engine. These are the magnetos. There are basically 2 magnetos in here that feed 2 distributors that fire the spark plugs. We'll talk more about the unique cowl flaps that are unique to the Birdcage Corsair here in a minute. But back here is the very rare blower section. If you look on the placard of the engine, it talks about the 3 blower ratios. These supercharged engines are basically running in low blower all the time. One stage, the bottom stage of the blower, is always engaged, and then you can go to the second stage blower and the third stage blower by changing the gears in the transmission through this here, through a control in the cockpit. So the basic procedure is you need to come back onto power a little bit as you're climbing out before you engage the next stage of blower, and then come back on the power, and you've got instantly more manifold pressure thanks to this centrifugal flow compressor. And then it blows into a Bendix 3-barreled pressure carburetor, which in this model of engine is a updraft carburetor this way. Other engines, later model engines, they spun this accessory case around, and a lot of those carburetors were downdraft pressure carburetors. And of course there's the signature pink primer.
Salmon.
What do you call it?
Salmon.
Salmon, that's right. Get your colors right. That's unique to the Birdcage Corsair as well. Now when I say it's always in low blower, technically according to the manual that's called the neutral position, but it's not a neutral position, it's still blowing. So there are effectively 3 stages of blower. Now of course the radial engine is an air-cooled engine, it's tightly cowled, and you control the air cooling with these cowl flaps. Now on the Birdcage Corsair it has a lot more cowl flaps, which these guys are building from scratch. We'll take a look at this spot welding process here in a minute. But of all these cowl flaps, they ran individual little hydraulic actuators for each cowl flap on the Birdcage Corsair. A complicated little system, a hydraulic system to open and close these cowl flaps. On later model Corsairs, they ran a single big pump here and then a series of pulleys and cables that pulled the cowl flaps in and out. And if this failed here, the cowl flaps would automatically slowly open up and cool the engine, so you wouldn't cook the engine in the event of a hydraulic failure. So a complicated little cowl flap system on the Birdcage early model Corsair. Okay, we found the actuators for these cowl flaps. This is one tiny little actuator here, one of 18 I believe it is, and here's the actuator mounted on the slipper, which is this, come on in here Tim, which is this piece here. Here's the slipper that the cowl flaps slide on, and then come on in here and you can see here's that mount, and the actuator mounts right there, just like that. Now here's a bunch of the brand new cowl flaps being made spot welded. We'll go over and take a look at the spot welding process, creating these brand new from scratch, from the plans, original plans. 90,000 spot welds so far on this spot welding machine from this shop. Here's the pans for the cowl flaps. Like a lot of this manufacturing, it starts out as dead soft aluminum, gets stamped out, and then worked from there. And then all these things are run through this 60, what'd you say, 60 ton? 60 ton press, big blue. Hydraulically smashes them in the dies. It's easier to train. Are we rolling? So how do you recreate a Corsair from scratch? Well, first you start with the plans. You have to have acquired the plans many years ago before liability took away the ability to acquire the original plans for the Corsair. But even with the original factory plans from World War II, those plans are just full of errors. So you start with the plans and then you start with an original part. So you back up the plans with an original part to verify all the dimensions, and then you got to create the dies to stamp these parts out from those dimensions, verified between the two sources, and then start stamping out the parts brand new from your brand new dies and put them in that 60-ton press over there. And so if you're gonna make one, you might as well make dozens of these Corsairs. So if you're going to this whole effort, you can supply enough parts for the entire Corsair inventory that's left in the world today. So because of the intricate double compound curves found on the Corsair, a lot of the components got to be spot welded. Spot welding 2024 alloy aluminum is the hardest, most difficult stuff in the world to spot weld. It has a very narrow range of resistance. This is resistance welding done by this 125 kVA spot welder here, and has a very narrow range of resistance in which to work with. And we had the data up here, but it's going to be, what's the volts and time you're going to put on this today?
24,000 amps.
24,000 amps for 60 milliseconds to achieve this spot weld right here. In order to get the correct resistance in this part before you can make that happen, you got to wash it with a acid etch right there. And here in the finished product, you can see where this acid etch was placed on the component here to get the correct resistance to make the perfect spot weld, so that you can build a Corsair with these intricate compound curves. Double flush riveting simply wouldn't work. Okay, 24,000 amps for 60 milliseconds on this spot weld. He's running with his foot there.
Hear that little chirp?
That's one as well.
Hear that little chirp?
Uh-huh.
It's like our bird nest. That's the amp.
Oh, that means you're hitting the amperage correctly?
No, that is the amperage going through the part.
Oh, yeah.
That's like the bolt of lightning you hear.
Uh-huh.
That's the buzzing sound.
That little squeak.
That little chirp is the actual amperage going through the metal.
And there it is.
Look at that.
Done. You want to be careful around these machines. There's a giant magnet working right in between those two arms there. Here's an example of some of the old plans. So when you get those plans and verify all the dimensions from a original part, you can put all that into SolidWorks now to create the dimensions you need to make all your parts. There's the cutaway view. And there's the action. All in SolidWorks. A CNC milling machine to make your parts that you created on the SolidWorks. Just input it into the program. Here's the center section of the Birdcage Corsair, and where it gets its name is that canopy section right there. Later model Corsairs, of course, had a bubble canopy for increased visibility. Now here's a aft fuselage section from the Birdcage Corsair, and there's the scallop portion of the canopy so that the pilot could turn around and look behind him, and here's your armor plating. But one of the drawbacks of having the Birdcage, I mean, you got to do this to get the visibility, but now you've got reduced a smaller amount of armor plating protecting the pilot. So a lot of these Corsairs were field modded later with a larger armor plate. But this little cutout here is an automatic life raft was located in here. And I'll go show you the cover. And here's the inside skin to this life raft cover. There's going to be the external skin of the aircraft mounts on the outside here. And this is all done by hand forming in this jig here with these hammers. And when I say automatic, the pilot would deploy the life raft from the cockpit, and by the time he got out of the airplane, the raft would be ready to go. And here's another one of these life raft covers where they're going to get the external skin riveted to it or spot welded to it. Let's go inside the cockpit of this Birdcage Corsair and see what we've got so far. So, of course, there's the Birdcage canopy, which gives it its name as the early model Corsair. Pretty standard set of instruments up here on the instrument panel. But I want to go over some of these controls here. First off, we've got the lock for the wing folding mechanism here. We got the wing fold mechanism right here. We've got a bomb rack location right here. We'll get the number of hard points here in a minute. We got the trims. What do we got? Aileron and rudder trim here. Elevator trim right there. There's a tail wheel lock and unlock is going to go right there. It's not there at the moment. Throttle quadrant. You got your propeller control right here. You've got your throttle right there. You've got your supercharger right here. Remember those 3 stages of blower right there, and then a mixture control right there. Now let's go over this landing gear and dive brake system. There's the landing gear up and down knob. So when you raise and lower the landing gear, you get all 3 gear, the 2 main gear and the tail wheel. That has a 200 knot limit on the tail wheel doors. The tail wheel doors are the limiting factor. Now the dive brake system is very interesting. To lower the dive brake for a dive bombing run, you throw that switch right there, and the dive brake in the Corsair is the main landing gear. Remember on the main landing gear, that big plate on front of the gear? And that main landing gear on the Corsair is so strong for its carrier operations that you can lower the 2 main gear all the way up to VNE, the maximum speed of the aircraft. But you cannot lower the tail wheel. So that's why they got a separate dive brake versus landing gear system in the Corsair. I like that checklist right there built into the panel. Now we're underneath the Corsair. There's this center section of the fuselage, and here's the bent wing part of the wing. The bent wing bird, as the Corsair is known. There's your main landing gear mount with that intricate angle swiveling mechanism right there that makes the Corsair have the short, stout landing gear for carrier operations. By bending the wing like this, intricate design, they were able to build a gear stout enough to handle carrier operations and at the same time clear the propeller. Some 13-foot diameter propeller, I think it is. So now we're looking up into the cockpit from underneath, and just forward of the cockpit here is the fuel bay. What'd you say, 230 gallons or so of fuel in a rubber bladder cell mounted right here, and then just forward of that is the firewall and the engine. So engine, fuel, pilot. So from combat experience, the Birdcage model differs in the later model Corsairs in the ability to drop your tanks in the event of combat. The Birdcage Corsair had additional fuel besides this center tank fuel of about 50 gallons in two 50-gallon tanks in the wings. Were those wet wings or was those bladders? Wet wing cells in the Birdcage Corsair. In the later model Corsairs, they got smart about this additional fuel and built this into the wing right here and allowed them to mount droppable fuel tanks so that in the event that they get into combat, they could just pickle the drop tanks and go to war. Whereas with the A models, you couldn't get rid of that fuel. And of course, these mounts for the later model Corsairs are made out of magnesium, which corrodes easily, so they gotta make some brand new ones. Here's the flap actuating mechanism right here. Remember, there's three main flaps on the Corsair to get around that bent wing. Right now they're forming a skin for one of the flaps. Watch your fingers. So that's how you get a double compound curve. You see the airfoil shape and the curve, the bend in the flap. There it is. Kind of like a ring cowling.
Pretty good, man.
Okay, here's the middle flap on the Corsair, and that's the piece of aluminum they're bending right now, or forming right now. It's going to be this bottom piece that goes right here. And here's an original one. See the compound shape of that? So you got the airfoil plus the bend in it as it bends around the wing for the flaps. Of course, that's dead soft aluminum, and then they got to heat treat it after they're done forming it, working with it. Got enough Clecos? Over here, they buy their Clecos by the ton, about 130,000 Clecos in stock right now. Clecos are the things that hold the sheet metal together temporarily while you're working with it and riveting it together. And they just come in and out like this, like that. Pair of Cleco pliers. Holds it all together while you work with it. So here's the rest of the flaps. There's the center flap. Here's the outer flap with the notch in it, and the inner flap here. Got sheet metal tools. Back up enough so we can see the whole wing here a little bit, and then come on up to me.
Half is oil cooler, half is intercooler.
All right. We rolling?
Yep.
Okay, so you know the Corsair has these two distinctive openings up here, and the distinctive sound of the Corsair comes from the air moving through this system here. Let me show you around this air system here. Cooling. So air's going to come in through the hole here. It's going to go, some of it's going to pass through an oil cooler, which is going to be located right here. Then there's a series of vanes that passes the air through a intercooler. here, and here. This intercooler, of course, is what cools the supercharged air. When you're in second and third stage blower, you're compressing that air. It gets hot. It needs to be cooled back down before it's fed into the carburetor. So the cool air comes in through here, moves through these coils, and then is discharged out the bottom of the aircraft. Hot air from the blower is plumbed through the top of these heat exchangers and then comes out this duct here into the Y duct and up into the carburetor. And all this air movement is what gives the Corsair its distinctive scream when it dives. And here's the Y duct for the intercooler that ducts the blown air up into the carburation system. Here's another look at that landing gear mechanism here, and here's where that dive brake board is on the front of the landing gear where it recesses into in a center section. So how do you jig one of these aircraft up? We've talked about this before in prior updates, but you got to create your own jig from scratch. You don't do it from the drawings because the drawings are simply not accurate enough. You got to take a existing aircraft that's in good shape, that's not all bent up, and build the jig around the existing aircraft. You weld up the jig, but then, as you know, as you weld, things move. So in order to get the final fit, you come on in here, Tim. In here, you epoxy these parts in here on a slow setting epoxy to get this point exactly located where you want it. And you do that with each of the main attach points, and that you now have a jig to build multiple aircraft with. This is a Birdcage Corsair outer wing panel with flaps and ailerons. Notice the ailerons, they're made out of wood, 4 different species of wood, mahogany, spruce, and poplar, a few others. But the early, in the prototypes, or the beginning of the Corsairs, they attempted to use metal or aluminum for the ailerons. They had problems with aerodynamic flutter and other issues, so they switched to wood. And apparently all of the Corsairs have wood ailerons. The flaps on the Birdcage Corsair are made of fabric. They're aluminum frame, but made of fabric. Because, remember, the A model, or the Birdcage Corsair has a wing tank. It did not have drop tanks that they could drop in combat. And this fuel tank was located right about here, about 50 gallons inside the wet wing. But they did have rocket launchers somewhere around, no, later models, they added rocket launchers right about in here. And of course, you can't have rocket launchers in front of fabric, open fabric flaps. So that's when the flaps became all aluminum, was with the later model Corsairs. Now let me show you around here a little bit more. The 350 caliber machine guns would mount right here, 1, 2, and 3. We're looking at the top of the wing. These are the ammo boxes. This is where the belt feeder would feed through the ammo boxes to the 3 guns. Ammo bay here. Again, fuel tank down in there. It's a wet wing, sealed wing fuel tank located right there. And this is the amazing aileron droop mechanism, which I believe is unique to the Birdcage Corsair, where the ailerons would droop with the flaps. They got away from that on later model Corsairs, but quite a bit of monkey motion in here to make that happen. And here's the way that droop linkage works in SolidWorks. So only the first 324 or so of the Birdcage Corsairs bothered with the aileron drooping mechanism. Flapperons. Looking at the bottom of the wing, the shell casings would be ejected through these ejectors right here, each one located a little different place for each gun, and the casings would go through there, and the clips that held the bullets together would fall through this chute here. So casings there, clips there. Give them the whole 9 yards. Here's an outer wing section for a later model Corsair -4 with the 4-bladed prop. There's your metal flap, no aileron drooping mechanism, and there's a little better view of the ammo boxes in position. And no wet wing fuel tank, drop tanks instead. This is the top of the wing. Here's the bottom of the wing. So he's got a bunch of these wing jigs here, I believe 8 of them, and same thing, you got to build them, these jigs, starting with a good wing to start with. Here's the leading edge section where the guns come out of the ports right here. Oh, smells good in here. Is the paint booth. There's the fabric going on over the wood aileron. This is the Farnham machine that does the double tapered leading edge skins for the Corsair. You can roll the intricate curve that you need for the leading edge as well as the taper using this Farnham machine from 1942. Where was it? Cherry Point? Yeah. Marine Station, Naval Air Station at the time. 1942 machine. For more on the history of this airplane, see our previous posts on this aircraft in the description below. Well, excellent. Thanks for the tour today. It's just an amazing shop to see what it takes to get one of these things going again, and the incredible complexity that these aircraft represented back in their day. What kind of, everybody's asked you this, I'm sure, what kind of timing do you think before you might get yours going?
We're hoping Birdcage will fly in approximately 3 years.
3 years time. Get cracking. And are you still always looking for sheet metal help around here?
We're always looking for talented people that want to work on the Corsair. It's a very difficult airframe to work on, but it's a very rewarding and fun airplane to work on. And we have a great shop and environment to work on the Warbird. But yes, we're always looking for additional people.
It's nice and warm in here, I'll tell you that. All right, thanks, Chuck.
All right, thanks, Juan. Good to see you.
See you here.